So I'm continuing my work on the new adapter plate, and I used transfer screws to get the positions of the other holes in the block, and those are all drilled out to to 10mm to take an M10 bolt. And I then turned my attention to the starter motor location, and if we have a look at the old plate, don't know if it shows up on camera very well, but just looking at this plate, the holes weren't very good, and in fact getting the starter motor on and off was a little bit tricky. You know, it does tuck in relatively tightly towards the side of the block, and is an awkward weight to hold whilst trying to get the bolts in and out, but it seemed that it was more difficult than it should be. And yeah, the alignment of the tapped holes in the plate to the bolt pattern on the starter motor was not good. There was also a spacer plate currently lying on the floor. I'm trying to work out what's going on with this plate, really. It's clearly been punched. You know, it's not milled out. You can see the shear line on it, although it has been ground back in places. Some holes have been elongated. This hole does not match the hole in the register on the starter motor casing. This is a 3-inch diameter register, 76.1mm. Quite why it's an inch dimension, who knows, but apparently it is. And yeah, this may be an original alpha plate, but it's perhaps that circle has been modified to get everything to bolt in place. So my next thing to investigate was the depth of engagement between the starter motor gear and the ring gear on the flywheel. And this was a little bit tricky to see what was happening, but it looked as if I was getting 50% depth of engagement or less, as the original plate had been made. And the starter motor is in bits partly because it just makes it easier to handle all the parts, you know, getting rid of the main bulk of the weight, but also because there was a fair bit of wear. It wasn't worn out, but it was worn. So there was an oilite bush in the nose of the housing, and I had some oilite bushes in stock, but not the right size. So I've got you can buy bushes for these starter motors, but they are relatively expensive, whereas a bush with the right dimensions, but inside and outside, but very slightly too long, is about £3.50 delivered. There are 2 bushes in this overrun clutch and gear assembly. You can just see the end of one there, and those are a custom size. It's a 12mm bore and only a 13.5mm OD, and a standard oilite bush was a 15mm OD. And I can buy a complete assembly for £20–25. Not a genuine Bosch one, but certainly a Magneti Marelli branded one with a part number that cross-references. But I looked through the bushes I had, and I had some bushes that were the right ID and a suitable, well, they were over length, but reducing length is easy. They were 15mm OD, having been sold for Motor Morini valve gear, but without the information that these wouldn't fit, but would need to be machined to fit. And I went with a different solution on the Morini valve gear, but it meant I had these things lying around in a drawer, and I was able to skim them down to the 13.5mm and rebush this gear. Didn't take all that long and saved me waiting around for everything. So now, with this assembly a decent fit on the shaft, I set both this shaft and the flywheel up on the bed of the milling machine, and sadly I didn't take any footage of this, but I had the flange supported on some parallels and clamped down, was able to find the centre of this shaft, push the flywheel into a suitable depth of engagement, and there is some information online about suitable tooth depthing, and generally speaking a figure of between 40 to 60 thousandths between the tip of the tooth on the gear and the inner diameter at the root of the teeth on the flywheel is considered suitable. So 40 thou is basically 1mm, so I just used a 1mm drill bit shank, got everything positioned on the mill, measured the centre of the flywheel. In one axis it was off by less than 1mm of being in line with the other shaft. So there is a cosine error due to that, but it's so small with that offset that it can be ignored. And I got a centre to centre distance of 156.4mm. So I then made this little alignment tool. So this has a 15mm OD and fits nicely into the pilot bearing on the crankshaft. And again, using the DRO, made this 12mm drilled and reamed hole at the 156.4mm offset. And I'm not going to be able to set it up one-handed, but by using a Morini rocker shaft, which is 12mm OD, and some spacers to get it all sitting parallel to this bar, I was able to set the gear up on that shaft, aligned by the plate, and just do an in situ check of the gear engagement, which I was happy with. And then by using a transfer punch in the 12mm hole with the adapter plate mounted to the block, flywheel removed, I was able to come in and scribe an arc at that. Yeah, you can just see it at that 156.4mm. The Sharpie line is just taken from the existing plate, but the motor is sitting a little bit low, and was hitting against the casting down here, which might have had a little bit of relieving done by the previous builder. So I shall be just moving the mounting point up a little. So once I've chosen a centre line, I'll set this plate up on the mill and cut this clearance in with the boring head, and I can then do the final alignment to get the 3-hole pattern for bolting the starter on. I have made a new spacer plate, which is an accurate fit onto the register on the starter, and the mounting holes are a fairly accurate 8.5mm diameter, so I could again use a transfer punch, get those holes accurately lined up. And I may add some extra fixings to just keep the alignment from drifting, because obviously there's a little bit of wiggle room on the bolts. But that should get the starter motor issue sorted out. And the starter motor, I say I'm just waiting for this bush, and I'll get a clean up and a reassembly. And I will just go and get the exhaust manifold down out of the loft, but it's a standard exhaust manifold and a standard starter motor and a standard starter motor mounting position, and I can mount it as low as clearance allows, but I may just equalise it in the space and check the clearances, but it should be fine given that it's all effectively a standard setup at that point. So I've got the starter motor, or at least some of the starter motor. I just have the front nose casing and the solenoid bolted on, mocked up in place, and there is clearance to the heat shield. Very much glad I pulled the manifold down out of the storage and put it on there. Can't really cheat any more space. This is all dictated by the original Alpha setup. This is all pretty much dictated by the original Alpha setup. It would have been tight on that as well. And I have my alignment bar in place to get the center distance set. So it is a little tight in the flywheel spigot, but that just has the 2 posts with the correct distance set between them, and the starter motor casing currently has the sintered bearing to support the output shaft is not in place because that was worn out and is being replaced, but that made using the alignment bar quite easy. Just have to get everything into the right alignment, and then the needle roller bearing in the crank tends to just put up some slight objection, but that goes in, gets all the alignment done, and I've got 2 clamps in place, and the black rod you can see is a transfer punch. So I'll shortly be taking the manifold off and marking that first hole, and then moving the clamp and doing the next one, and so on. Well, the bush turned up and is installed, and I've got all the mounting holes drilled, and if I come in the back and do it from the front, that is just about the right amount of engagement and lash in the starter gears. So very happy to have got that bit done. We're all set up with my alignment tool for the bell housing, and I've got the starter motor nose casting bolted into place because I just want to see whether I have to do any cutting of the additional cutting of the bell housing, since the starter motor nose will now be protruding an extra 5mm because the plate is 5mm thinner. So I know that getting the bell housing on and off the alignment tool is a two-handed job, because it's actually a really close fit. So we'll come back when I've got that slid on. Well, the good news is that the clearance that's been ground in this bell housing is still more than adequate to clear the starter motor, and in fact there's no need for there to be a break in the outer skin. Although it's something I'm slightly reluctant to do, I think I'm going to modify the bell housing that's on the replacement gearbox, because it looks like the amount of modification is quite minimal and is confined all on the inside. It may not even break into the location dowel position, so I'm less reluctant to do that now. It solves the problem of the alignment between the bell housing and the main case, and although that can be dealt with, it is possible to swap bell housings. It'll be much better if I keep the bell housing that matches the main case. So what I've done is use a digital angle gauge, using the top face of the water pump as a reference, and the top of the bell housing. I might redo it using this interior, just to get them at the same angle. I mean, we're talking about fractions of a degree. You know, if the engine leans over slightly, it's not really an issue, and the angle it's sitting at now is one that's giving the best clearance for the starter motor, so I probably won't get too fussy. What I've done on this bell housing is all of the holes were 10.5mm as clearance for M10 bolts, and I've just gone through with a 10.5mm drill to chase out any corrosion and get that cleaned up. So I've got a 10.5mm transfer punch, so I'll clamp the bell housing just to stop it moving, go round and mark all of those positions, and then I can take it over to the mill and get them all drilled and tapped. So I do have a little problem to solve with this particular bolt location. This has got the locating dowel behind it, so it's counterbored, and also the bell housing sits above it, so it would need to have a countersunk head or a bolt coming through from behind into a thread. There isn't really enough thickness of plate left because of the counterbore for the dowel to put a thread in there, and I forgot about it anyway. There wasn't enough, but at the stage I was making those location holes, I forgot about it anyway. So what I think I can do is I will end up using countersunk bolt, and there may just be room to sneak in the M10 if I rotate the bell housing ever so slightly clockwise. I've got the option of just reducing the head of the countersunk bolt a fraction so that it doesn't intersect with the bolt, or what may be an easier solution is to go down to an M8 bolt, which definitely will have enough clearance, and just putting a little bit of a sleeve on it to centre it in the hole. Well, it doesn't really even need that probably. But I do really want to get a bolt in here. We've got the same problem on the other side, but there is a bell housing bolt just above it. So on the original plate, this is the countersunk bolt, that's the bolt into the block, and that's the bell housing. So we're pretty close to this location. On this side, the nearest one is up here, and then we haven't got one down here, so it would be quite nice to get something in there, even if it is only an M8. But that's something I'll get a final measurement on once I've got the bell housing on, happy with the alignment, do the transfer punching, and then we can work that one out as we go. Well, I got all of the new holes drilled into the adapter plate and got ahead of myself slightly. I've got the flywheel mounted up because I'm looking at some clutch stuff. In the end, it was an M8 bolt that sneaks in beside the countersunk screw, and rather pleasingly, the countersink I have is the perfect size for these bolts, because the diameter you see is actually a parallel counterbore. So you've got the conical seating and then a parallel sided section, so that it doesn't extend much beyond the diameter of the head. That's really pleasing when that's possible. Makes it look much neater than an oversized countersink. So I've got the bell housing profile roughed on, and an extension to it on that side because of the starter motor on the back. So that's just some preliminary looking at how I'm going to cut the whole profile down. So I'm just going to do some double checking on the clutch setup. With I now have splines protruding beyond the clutch disc with it against the flywheel. I just want to check that again. I did a rough check. I'm going to do it slightly more accurately. Need to look at the pilot bearing arrangements that's going to be mounted in the flywheel rather than in the crank. That's all pretty easy to sort out. And I'm looking at the clutch stack up height. Got an idea I want to try out that will involve me having to make a modification to fit in the clutch cover. Just need to put things together temporarily to see if it's all feasible. Well, that is the adapter plate essentially done. I've roughed out the overall profile on the bandsaw, and there'll just be some finishing to do, rounding the corners, smoothing everything off, making it look nice. I did in the end countersink a third hole, as had been done originally, rather than relieving the bell housing in that position, mainly because the other countersinks turned out so nicely that I decided to replicate that again. So the next thing we'll be moving on to is sorting out the clutch release mechanism.